Standard position for an angle always starts with the x-axis as what we call the initial side. The x-axis going positive. So let's take an angle such as 120 degrees, like this. This one here is called the terminal side. So you have an initial side and a terminal side, and your vertex is always 0, 0. So even if we're to go farther, like over to here, say to 200, let's see, it's 270 to 55, let's say we go down 15 degrees, say 255, that would come all the way around to here. This would be the terminal side, this would still be the initial side. Now, the next thing to know from this section is about radian measures. And for radian measures, let's start with the idea that from 0, 0 out to here, out to the end of the unit circle in particular, this is a measure of 1 unit. The radian measures is of the circumference. So we take this amount of the radius and let's go the same distance to say about here, and this is about that 1 unit. If you take this and curve it around, and then go further to about where 2 would be, and then go further to about where 3 would be. Any place along here, that's the radian measure, is the circumference measurement. This extra little bit here is about 0.14, which means when you get to this point, that's at 3.14 units. You should recognize that number as pi. So radian measures are often put in terms of pi because if you have a radius of 1 unit, the most basic unit circle measure, then this is 1 pi. Going all the way around a second time, not only was this 0 where we started, it is also 2 pi because it's 6.24. And then of course half of this, when you get a 90-degree angle, would be pi over 2. So this is 180 degrees, that's 90 degrees, and it's pi over 2. So remember radian measures as the measure of the circumference, and it's based upon how much the radius is here. Now let's go into a couple other concepts from this section. A coterminal angle is one where if you go around the circle, okay, I'm actually thinking 2 different things here. Okay, you have an angle such as, let's say 135 degrees here. If we were to go all the way around again, that would be 135 degrees plus 360 degrees because you went around again. So what you have, 6, 7, 8, 9, 3, and 1, that's 495 degrees. So 135 degrees is the same as 495 degrees. It terminates in the same place, and both of these are actually the same. They're equal to each other. You could even go backwards to it. So you would be starting at 0 and you would be going backwards, but you'd be thinking of it as 360 and going down or going negative. So actually you shouldn't think of it as 360 because that would be after you come around once. So you think of it as 0 and you're going negative that way. So what you have is this original, if you'd gone 360 and then subtract 135, that's often one of the easier ways to get that. So let's take 360 and subtract 135, and what you have is 225. Let's check on those numbers, 3, 5, 360. So this is a negative 225 degrees if you have the initial side here and come this way to get to the terminal side. So 135 degrees, 495, and negative 225 are actually all the same thing. They are coterminal. That's in terms of degrees. We do the same thing if it's in terms of radians. So this measure here at 135 degrees is the same as 3 pi over 4. So this, well, I shouldn't measure it like that. I should measure it with this. So the circumference measurement is 3 pi over 4. The angle measurement was 135 degrees. But just like here, we could add another 360 or subtract a 360 from there. We could do the same thing here. So here, if we go this way around again, it would be 3 pi over 4 plus 2 pi, which is what it would take to go around again. 2 pi, you would have to make that over 4, so you would have 3 pi over 4 plus, you're going to make that 4, it's going to be 8 pi. So 2 pi and 8 pi over 4 are the same, but we can't add without having the same denominator. So we get 8, 9, 10, that's 11 pi over 4. So if you go around an extra time, this is also the same as 11 pi over 4. These two are the same. And we could also have a negative where you're going backwards. So there's a number of ways to think of that, but one of them is to take 2 pi and subtract from it 3 pi. Well, actually, yep, because that would be like going around once. I'm thinking here, I have to be careful. I'm not subtracting, or I'm doing this way. Well, here's one better way to think of it. If I were to go that same amount this way, that would give me an angle of 3 pi over 4 pi. This one's 5 pi over 4. So if I'm coming this way, it would almost be as if I was going this way, but going the other direction. So it would be a 5 pi over 4 distance to go this way, but it would be a negative 5 pi over 4. Okay, so rather than do it that way, I'm thinking of going this way, thinking about that 5 pi over 4. So negative 5 pi over 4, which is the same as 11 pi over 4 or 3 pi over 4. Okay, the next thing to see is to convert between degrees of radians and degrees. So what you want to remember is the idea of having pi over 180 as a multiplier, or 180 over pi. Here for this one, to change from degrees to radians, we need to have pi in it, just like all of these other radian measures had. And that's what you will usually use as a measure for the circumference, unless you multiply it out and turn it into a decimal. In this particular case, we're going to multiply by pi over 180. And then we're going to see, 45 goes into 180. Actually, it goes exactly into it 4 times, but some people won't realize it. We could think, wait a minute, 15 degrees goes into 3 times, and it's 12 times, then 3 goes into 12 4 times. So that's equal to pi over 4. This one over here, 2 pi over 3, we're going to multiply by 180 over pi. Pi cancels out. 3 goes in 18 6 times, so it's actually a 60 here. 2 times 60 is 120, and we do 120 degrees. You have to remember the degrees. Over here we put RAD for radians. Now notice that in this one we're using pi on top, here we're using pi in the denominator. Reason, because in this one we want to have pi there, so we put it on top, so when everything else cancels out we have pi. In this one, pi is on the bottom, so it can cancel out with what was given to us on top. That's one way that might help you to remember which one you use, or whether you have pi on top or on bottom. When you're getting rid of radians and changing it to degrees, you want to get rid of pi, so you have that on the bottom. Okay, take a moment to do these two yourselves just as practice. About 5 seconds I will start doing them, so you can stop the video and then you can come back to it in now about 3 seconds, or come back to it whenever you're ready, and I will start talking on my time in about 3 seconds. Okay, so on this one we're going to multiply by pi over 180. This one, we have 60 goes into this 4 times, and 60 goes into this 3 times, so we have 4 pi over 3. And that's radians. Here we're going to multiply by 180 over pi, so the first thing we can do is cancel out pi. 6 goes into 18 3 times, so it's really 6 goes into 180 30 times. 11 times 30 is 330, and so it's 330 degrees. Okay, the last part of this section we're going to look at, in particular, is on arc length. I'll straighten this out a little bit. Okay. So let's say we have a radius of 12 units and an angle here of 60 degrees, and we want to know what the arc length is from 0, 0 to, or from 1, 0 to this point. And I'll put a question mark here. That's what we're looking for. The thing to remember is that arc length is equal to r theta. R is the radius, and theta is the angle measurement. I'll put parentheses here, and I'll put angle measure. So this one's pretty easy because we know that the radius is 12 units and the angle measure is 60 degrees. But here is the first major thing to remember about, I guess second major thing. The first major thing is remember this little formula. The second one is remember that you can't do it in degrees. You have to change it into radians because the circumference is measured in radians. So that's where you have to take the 60 degrees and you have to multiply it by, going from degrees to radians, pi over 180. So pi over 180, 60 goes into 183 times, so it's 12 times pi over 3. 3 goes into 12 4 times, 4 pi. That is an exact answer because it's not rounded in any way. If you are supposed to give it as a decimal number, which would make more sense to most people, you would approximate it and calculate it with a calculator. It would come to 12.56, but there's no need to go to 2 decimal places in this. You can just round this to 12.6, and that would be the most reasonable answer here. And I have to remember units as well. So the steps to this are to remember that the arc length is equal to the radius times the angle measure. The angle measure has to be changed from degrees into radians, unless you're already given that, but you probably aren't. Or you may even recognize that 60 is pi over 3, or other ones are whichever ones, as you memorize the unit circle. And then you multiply it out, and you can give an exact answer or an approximate answer depending upon what's asked. If it's not asked either way, either one of them can be acceptable, but it is usually more acceptable to do the approximate number with the decimal. Both would be acceptable in this case, though, since it doesn't say one way or the other. Now, let's take where there is a radius of 10 inches and an angle of 120 degrees. What is the arc length here? Go ahead and do this yourself. Stop the video, take as much time as you need, and then come back to it. In video time, I will start in about 5 seconds. Okay, so I know that the arc length is the radius times the angle. That means it's 10 times 120 degrees. I'll come over here to do 120 times pi over 180. The zeros cancel. 6 goes into this twice and this 3 times. So that's 2 pi over 3. So that's equal to 10 times 2 pi over 3. So that would be 20 pi over 3. And I'm going to give the more useful answer of putting it in decimals. That would come to 20.93 inches. But that 3 either makes that a 9 or the 9 makes that a 21. That's so close to 21 that the most reasonable answer here would be to say 21 inches. So that would be the arc length that we're looking for. If you have a radius of 10 inches, then at the angle of 120 degrees, the circumference, this part of the circumference, is 21 inches. So that part of the length of that arc is 21 inches, approximately 21 inches. So in this section, the focus was on the standard position, understanding what radian measures are, recognizing and being able to make coterminal angles in degrees or radians, being able to convert between degrees and radians both ways, and being able to calculate an arc length given the two basic pieces of information of the radius and the angle measure.